Okay, hello everyone. So in this session, we will be looking at the third method that we are going to use to find roots of functions. Okay, so this is called as the Newton-Raphsons method. Okay, and actually this is the easiest of the three. So let's see what we do here. So here we will be given one starting point, okay, which we will call, actually let us call this as x naught. Okay, which is somewhat close to the root of f of x. Now, what does that mean? You don't have to worry about, but ideally you would want this to be closer to the root of the function. Okay, and we construct a sequence xn of points that comes closer and closer to x. So let's see how we do that using the diagram. Okay, so we start with some point x naught. Okay, and when we start with this point x naught, we look at its image here. Okay, we look at the point on the graph x naught comma f of x naught, and we draw the tangent at this point. Okay, so when we draw the tangent at this point, after we draw the tangent at this point, we look at where the tangent hits the x-axis. That would be our x1. Now we go to x1, okay, and look for the point that the value of right, this is where we're going to reach. This is x1 comma f of x1. Okay, so we look at x1 comma f of x1, and this is also f of x naught, not just f naught. Okay, then we look at the tangent to this point, that is my x2, and then from x2 again we are going to do the same thing. We will find what is at the point x2 comma f of x2. We will find tangent to that point and what. Now how do we find the tangent of the line segment? Sorry, how do we find the tangent to the graph of a function at some point x naught? Okay, so that is simply the slope of that line. The slope of that line would be, as you know, the derivative of f at x naught. Okay, and you have one point that passes through that line, that is x naught comma f of x naught. That is one point. You know one point that passes through the line, and you know the slope of the line, so we can find the equation of the line, the tangent to the point x naught comma f of x naught. Okay, so let's see what we do. So if we look at the equation of the line passing through the point, that's what we are interested in. The equation of the line passing through the point xn comma f of xn with the slope f prime at xn. This is the tangent. Okay, what is it going to be? Using the slope point form, this would be y equals f prime at xn times x minus xn plus f of xn. Okay, and so we want to find xn such that f of xn, I want to catch hold of what is xn plus 1. Okay, so let me draw it here. So at the nth stage, this is what I would have. This is my function. This would be my point xn. Okay, then we have this would be the point xn comma f of xn. okay, and the line is y equals y prime at xn into x minus xn plus f of xn, which would be this line. This line with the slope is the derivative, and so this is this would be the tangent. Let us extend it. Okay, so this is my point xn plus 1 comma 0, right? So this is so xn plus 1 is the x coordinate of the line when y is 0. Okay, so if you put y equals 0, so we know that this point lies on the line, so it satisfies the equation. So you can insert in place of y if I put 0, in place of xn plus 1, in place of x if I put xn plus 1, I get this. Okay, and from here we can compute what is xn plus 1 by simply first taking f of xn to the other side and then cross multiplying and doing what is required. Okay, so this is what we get xn plus 1 to be. So this is the next iterate in the Newton-Raphsons method. So a very simple method. So if we want to use the Newton-Raphsons method to find the root of f of x, which is sine of e raised to x, you can plot out this function on GeoGebra. It's a very nice function, you see. Okay, so sine of e raised to x, when x naught is equal to 1, the starting point you take as 1, correct up to 3 decimal places. This is what you would do. So you start with x naught here, okay, compute the value for f of xn. So this will be simply f of e raised to 1. Okay, so or not f of sine of e raised to 1, okay, or sine of e. Then you find what is the derivative. Okay, what is the derivative of f? We can compute the derivative here. The derivative will be nothing but you will need to use chain rule to find the derivative. So the derivative of sine is cos e raised to x. Okay, and this is a composition of two functions, sine and e. So this will be cos e raised to x into e raised to x. So plug in the value for when x is equal to 1 here, you will get f prime at xn. Okay, and now you need to find the next value for the next xn plus 1. So what will that be? That will simply be, so this value here is simply 1, okay, this x naught, which is 1, minus f of x naught. Okay, f of x naught is what? This, divided by f prime at x naught, which is this value. Okay, you compute this, you get your next value, and then you can find the value of f at this point, the derivative of f at this point, and you can compute your epsilon values also. Okay, what will be the epsilon value? It will be nothing but this minus this. Okay, and you keep doing this until you get the required error. Okay, so the root of the function correct up to 3 decimal places will now be 1.1447. Okay, so yeah, so some applications of the Newton-Raphsons method. By the way, the Newton-Raphsons method is generally the fastest of the three. Okay, as you can see, to find correct up to 3 decimal places, I have simply got it within these many steps. Okay, while I think, if I'm not mistaken, the bisection method would take you 16 steps. Okay, well, this is just 5 steps. Okay, so the Newton-Raphsons method to find the kth root of positive real number. So we can use the Newton-Raphsons method to find what is the kth root of a positive real number. So essentially what I want to do is compute what will be the xn plus 1. Okay, so suppose we want to find the kth root of a. What does it mean? It means we want to find an x such that x raised to k is a. Or in other words, we want to find a 0 of the function f of x equals x raised to k minus a. Okay, now you can simply compute what is f of x upon f prime of x. That will be x raised to k minus a upon k times x raised to k minus 1. Okay, and therefore if you look at x minus f of x upon f prime of x, this is what you will get. Okay, so from here we can tell what is going to be the next value given the starting point. If I want to find the root of a function, this is what the next value will be. And specifically in the case when k is 2, that is if I'm trying to find the square root of a, what do I get is xn plus 1 is half of xn plus a upon xn. Okay, so this is the simple formula. So your Newton-Raphsons table would look something like this. You would have xn, okay, and epsilon itself. So you can find what is xn. Your starting point of xn you could take. Okay, take some starting point. So maybe 1. Plug that value inside this. Take this, plug it inside this formula. You will get your xn x1. Take your x1, plug inside this formula. You will get what is x2, and continuously do this. You will get this thing. You keep doing it till your error drops. Okay, so this is how you're going to find, how you're going to use the Newton-Raphsons method to find the square root of a real number or any general kth root of a real number. Okay, we can also use the Newton-Raphsons method to find the reciprocal of an integer. Okay, and we are going to do it in such a way that we actually do no division. That's important. Okay, so if we want to find a real number x such that x is equal to 1 by n, that is x is the reciprocal of n, then it means that you can, this simply means that equivalently this means that 1 by x minus n or 1 by x is equal to n, right? X is equal to 1 by n if and only if 1 by x equals n. So taking the n on the other side, we'll get 1 by x minus n is 0. So basically we want to find a root for the function f of x equals 1 by x minus n. So what is the derivative of this function? It is nothing but minus 1 by x square. The derivative of n is 0 because that's constant. So compute what this value is, x minus f of x upon f prime of x. What you can see, you will get, after cancelling terms, you will get 2x minus nx square. And you can see this formula requires no division. We are only multiplying and subtracting. Okay, so the n plus 1th term in the Newton-Raphsons method would simply turn out to be xn plus 1 equals 2 times xn minus n times xn square. This is xn square. Okay, so this is the formula which you have for finding the reciprocal of an integer. Okay, so you can I will stop with this session here. Okay, and you can solve the exercises in the notes which are provided. Please make this change to the notes over here. In this this would be xn here. I had simply written x, so please make those changes. There are three exercises in Newton-Raphsons. Please see that you all solve them before you all come to the class for the next session. Thank you.